Bismillahirrahmanirrahim. Our next question is test the convergence of the sequence whose n term is n square root multiplied by n plus 2 square root minus n square root. Apply limit a is n tend to infinity. We have limit n tend to infinity square root n multiplied by square root n plus 2 minus square root n. The result is infinity multiplied by infinity minus infinity is an undeterminate form. Therefore, we divide we multiply and divide the function by n plus 2 square root plus square root n. After the simplification, after the multiplication and simplification, the result is 2 square root n divided by square root n plus 2 plus square root n. Now the function is in the form of f divided by g, and according to the condition, when the limit is the limit n tend to infinity, we divide the numerator and denominator by square root n. After the simplification, the function is limit n tend to infinity 2 divided by 1 plus 2 divided by n square root plus 1, and apply the limit to the numerator as well as to the denominator and each term of the denominator, and the result is the limit of constant is the constant. The limit when n tend to infinity of 2 is 2 divided by the limit of 1 is 1 plus the function is in the form of f divided by g. Limit apply to 2 is equal to 2, and when we limit apply n tend to n, the result is infinity plus square root plus the limit of 1 is equal to 1, and after the simplification, the result is equal to 1, which is not equal to plus or minus infinity. Hence, we can decide that the sequence whose n term is square root n multiplied by square root n plus 2 minus square root n is equal to 1. The sequence is convergent, and the limiting value of converge to the point n is equal to 1.